Hey everyone, welcome to the MTRW recap video for the 27th of April. So today we went over lessons 167 and 168. I know we kind of went through 168 quickly, so I might talk a little bit about it next week. Just a little bit. Before we start with the lesson though, let's talk about common mistakes in the homework. So this is the homework that you guys just got back, homework 12. Homework 12, common mistakes. First, I wanted to look at lesson 163, and there wasn't any one part of this in particular that was like more missed than the others, but I wanted to make sure we all are clear on the distributive property of division, which we saw 2 weeks ago. Okay? So the distributive property of division tells us that if we have a plus b as a sum and we divide it by c, then we're going to have a divided by c plus b divided by c. Okay? So we can take the divisor and the division operation and distribute it to b and a. Let's just see one particular example. So 5a, exercise 5a, it's minus 19 divided by 3, minus 2 divided by 3, and we had to solve that. Okay, so if we were to use the distributive property of division, we would get minus 19 minus 2 divided by 3, which is minus 21 divided by 3, which is just 7. Okay, so let's see the common mistakes. So error 1. I saw a lot of minus 19 plus 2 divided by 3. Okay, so the error here is in the sign of the 2. Remember that when we're pulling out this 3, we're not pulling out any minus signs. We're pulling out a positive 3. And here, the 2 has a minus sign in front of it, so we can either think of this as plus negative 2 or just as minus 2. Either way, we have to hold on to that minus sign here. Okay? So error 2, that was also common, is we got to the minus 21 divided by 3 step, and then the sign just drops. So again, this is wrong. Oh, I wrote that incorrectly over here. It should be minus 7. So it's good to check yourself. Here, we need to remember the minus sign. And the last error that I saw was actually reversing the divisor and the dividend. Be very careful. Even though for multiplication, it doesn't really matter. You know, for multiplication, you can either write it like a times b plus c or b plus c times a, and it doesn't make a difference. For division, it actually makes a huge difference, and the distributive property only works on the divisor. We're only allowed to pull out this divide by c part. Okay, so when we pull out the divisor, it has to stay in the divisor position. It can't switch to the dividend position. So to correct this error, we would have to switch these two. Okay, so one tip for you guys to do in general is to do one check just for signs. What do I mean by just for signs? Here, I mean skim through all of your work, go line by line, and just make sure that you're not dropping signs. You don't have to check if your numbers are correct. Just make sure that, you know, if you multiply two numbers, you didn't drop any signs. If you added and subtracted numbers, you didn't drop any signs. Okay. So the next question that I wanted to talk about was lesson 164. And this is question 3. So question 3 wanted us to simplify an expression when x equals minus 9. So it wanted us to calculate a is equal to 2 times x plus x divided by absolute value of x. Whoa. That's a handful. Okay, so I'm going to just plug in minus 9 first. So 2 times minus 9 plus minus 9 divided by the absolute value of minus 9. Okay, and I'm going to simplify this piece by piece. So I'm going to follow my PEMDAS here. I get minus 18. Not going to touch that plus. Then I have minus 9. Then divided by 9. And at this point, a very common mistake was to have a equals minus 27 divided by 9, which then equals minus 3. But this is wrong because we need to do the minus 9 divided by 9 first. This is by PEMDAS. So minus 9 divided by 9 comes first. So the correct way to finish up is a equals minus 18. And then we're going to do minus 9 divided by 9, which is minus 1. And this is going to get us minus 19. Okay. So I'll zoom out of this page and you guys can pause the video to just recap the homework if you want. Otherwise, I'm going to move on to recapping lesson 167. So lesson 167, it's about exponents, so we have to revisit them. But this is going to be a special case when the base is negative. And we only really touched positive bases before. So after we discussed this in class, we saw that, okay, if I want to find a to the n, where a is negative, then if n is odd, then a to the n is also negative. But otherwise, if n is even, then a to the n is positive. Okay. And I thought the best way to see this is through doing some examples. So the first example that we can do, let's just try minus 2 to the 5th. I know we didn't do this one in class, but let's just do it out. Using the definition of exponent, this just means we take minus 2 and multiply it to itself 5 times. Oops. Okay, so I'm just going to go one by one. These two multiply together to be 4. These multiply together to be minus 8. The next two multiply together to be 16. And the next two multiply together to be minus 32. So we end up with minus 32. And this is sort of what we saw with our rule. If n is odd, then our answer is going to be negative. How about the number part of the answer? Well, the number part of the answer, like just to put things into perspective, this is equal to 2 to the 5th. So as if the base were positive. So one way to handle negative exponents is just pretend the negative isn't there, calculate that exponent, and then decide the sign at the end. And another easy way to see why this eventual answer is going to be positive is because we have an odd number of minus signs. And we saw earlier that when we have an odd number of minus signs, our answer is going to be negative also. Okay, and then I'll do another example, minus 2 to the 4, or let's say you have minus 2 times minus 2 times minus 2 times minus 2. And here we actually have minus signs that we can pair up. And every time we pair up two minus signs, we can cancel them out. So another way of doing this would be, okay, these are both positive 4. This whole thing is 16. So again, the numerical part, 16, is the same as plain old 2 to the 4, without the minus in the base. Okay, but one thing to watch out for is that if I take minus 2 to the 4, this is actually not equal to the whole minus 2 raised to the 4. So why is that the case? This is because of PEMDAS, actually. Because minus 2 to the 4, you can think of as minus 1 times 2 to the 4. And this tells us do exponents first. So now we have minus 1 times 16, and then there's minus 16. Okay, cool. Here's one other example that I thought was really fun. So what's the sign of this number? Minus 1 to the 8 times minus 3 to the 5th times minus 5 to the 10th times minus 7 squared. We actually had a great discussion about this in class. Minus 1 to the 8th itself is going to be a positive number because we're taking a negative number, but we're raising it to an even exponent here. Minus 3 to the 5th is going to be a negative number, and that's because our exponent here is odd. This is going to be positive again, exponent is even. And this is going to be positive again because exponent is even. And then now we just have a multiplication of 3 positive numbers and 1 negative number. So overall, this is going to give us a negative product. So if you see a question and it's just asking you for the sign, or if it's just asking you, hey, is this number bigger or smaller than 0? All you have to do is look at these and check if they're odd or even. You don't really have to do any of the math out, right? We didn't do any of the calculations here. We were just checking signs. All right, so let me zoom out of this page so you can summarize the examples that we used for lesson 167. Okay, next up I had everyone do one of the exercises from the book together because it's good practice also for the distributive property of division. So I wanted everyone to do lesson 167, exercise 2D. And 2D is asking us to simplify minus 2 to the 5th plus minus 2 cubed, all divided by minus 2 cubed. Okay, so now is a good time if you want to try it on your own to pause the video. Otherwise, there are two ways, or two basic ways I can think of to do this. Solution number 1. First, I just want to use PEMDAS, okay? PEMDAS is telling me to do exponents first. I'm going to do minus 2 to the 5th. I have to calculate that eventually. That's minus 32. And minus 2 cubed, that is minus 8. So plugging into our expression, we actually have minus 32 minus 8 divided by minus 8. And then now we have minus 40 in our numerator and minus 8 in our denominator. And then we have 5. So this method works great if we happen to be working with bases and exponents that aren't too big. If I had bigger numbers here, I would have a much harder time doing the calculations. With minus 2, we're getting pretty lucky, actually. So here's a second way to do things. And it uses the distributive property of division. Actually, it could be the distributive property of multiplication, depending on how we do it, but I'll do the division way. So someone pointed out in class that both the numerator and the denominator, well, it has this minus 2 cubed. It'd be a lot easier if that minus 2 cubed weren't there. Or rather, if the denominator were 1. So if the denominator were 1, that means we'd have to divide it by minus 2 cubed. And this is legal as long as we do the same thing to the numerator. If we do the same, if we multiply the numerator or denominator or divide them by the same number, it's equivalent to multiplying or dividing the whole fraction by 1. Might be good food for thought if you hadn't seen that before. Okay, so what happens when we divide? Well, the denominator is easy. Becomes 1. I'm really happy about that. But the numerator, actually, I'm going to use the distributive property of division and distribute that divides by minus 2 cubed operation. So now I have minus 2 to the 5th divided by minus 2 cubed plus minus 2 cubed divided by minus 2 cubed. Okay? Well, this part is easy. We saw that in the denominator. This is equal to 1. How about this part? Our rules, if we use the rules for exponents, note that these rules don't change at all when we change to negative bases. We keep the same base, but we subtract the exponents. So this becomes minus 2 squared. So now we have minus 2 squared plus 1 overall, which is 4 plus 1. And now that's 5. So same solution, got it 2 different ways. Both are equally valid. Okay. So now's a good time to pause and look at the 2 types of solutions if you'd like. Otherwise, we're going to move on to lesson 168. So lesson 168 is again about exponents. But this time, the exponent is negative. So we are looking at numbers of the form a to the n where n is negative. And I honestly think the best way to get used to this is to see a lot of different examples. Let's first see 2 to the minus 5. Okay, so someone in class told me it was 1 over 2 to the 5th, which is true. But how do we see that using exponent rules that we've done before? Well, I can think of 2 to the minus 5 as 2 to the 0 minus 5. Right? And the reason I'm writing it like this is so I can work with 0, a number that is easy generally, and ideally positive 5. And we saw that when we subtract exponents, it corresponds to writing your number in this form, where you have 2 to the first number divided by 2 to the number that's being subtracted. Okay, and then this is going to simplify it rather easily. Your top is going to be 1, because it's 2 to the 0, and bottom is going to be 2 to the 5th. Okay, so the rule in general here is that if the exponent is negative, then we take 1 over the version with a positive exponent. So another way to think about it is we flip the numerator and the denominator. Okay, this sounds maybe confusing right now, but let's see a couple of examples. Let's do this example. 3/4 to the minus 2. The answer ends up being 16/9. And let's see a couple of different ways how. So the first way is I'm going to take the same idea as before. Originally we had 2 to the minus 5, and now we just stuck 1 over and got rid of the minus sign here. One way to do it is 1/3/4 squared now, right? We got rid of the negative. So now I have 1 over, okay, it's 3/4 times 3/4. So this is 1/9/16. And when we have 1 over everything, we flip. So we have 16/9. The second way of seeing this is I can use my properties of exponents. And I can go 3 to the minus 2 over 4 to the minus 2. We saw this property with positive exponents, and it hasn't changed for negative ones. So 3 to the minus 2 is 1/9, and 4 to the minus 2 is 1/16. So again, we can get 16/9. These two methods work great if you're comfortable working with fractions. And the last one is my favorite. It uses a little trick where if you have a fraction a over b and it's raised to some negative power, like minus c, maybe I'll call it minus n, then it's the same as just taking b over a, raising it all to the n. So in this case, we have 3/4 to the minus 2. If we match our expression here, we have 4/3 squared. And then we can solve 4/3 whole thing squared in any sort of ways we want to get 16/9. So I like that trick personally. This to me is the best way because it just gets rid of negative exponents really fast and you don't have to work with crazy fractions. Okay, let me just zoom out of this page so you can pause and recap it if you'd like. Okay, last one. Or actually, no, I want to add a couple more examples. So another one that we saw now has, well, you're going to introduce a negative number as the base. Okay, so there are a couple of different ways to do it. The first way is just take 1 over everything. So now it's 1 over minus 1/5 cubed, right? When we take 1 over, we can get rid of that negative sign in the exponent. And this ends up being minus 1 over 1/5 minus 1/5 minus 1/5, which equals 1 over minus 1/25, or 125. And this is minus 125. The second way of doing it is to use the trick from before. So in this case, minus 1/5 to the minus 3 is the same as taking something just to the 3, but we have to flip the inside. So by flipping the inside, okay, 1/5 becomes 5, but we keep the minus sign. Remember, taking reciprocals does nothing to plus or minus signs. And then at the end of the day, we get 125. So same method. A few more examples, mainly just to look at properties. So for instance, if I have something like 8/5 divided by 8 to the minus 6, I can still use the same properties. So I can still take 8 to the 5 minus 6, but now we know from working with negative numbers that 5 minus 6 is actually positive 11. So we can get answers like this. Similarly, if we have something like 7 to the minus 5, and raise the whole thing to the minus 9, it's still the same as taking 7 to the minus 5 times minus 9. We just have to be careful about signs up here. So here we're going to get 7 to the 45 still, positive 45, even though we took 2 negative exponents. Similarly, we saw that if we have something like minus 3 to the fourth times 2 to the fourth, they have different bases but the same exponent. We can multiply the bases and raise it all to one exponent. And here is the same story. We just have to be careful about signs or bases that might have signs. So I'll talk a little bit about this next week, but just keep in mind all of the properties of exponents that you learned about earlier in the year. That's all going to carry through even when your base is negative or your exponent is negative. Cool. That's it for today. Thanks.